Good evening, everyone. So, I welcome you all in Sapience Education. For more details, you can visit our website www.sapienceeducation.com. So, today I am going to discuss about the new chapter, that is mechanical properties of the solid, right? So, what is mechanical properties of a solid? So, we should try to understand this. So, first of before that, we need to understand what is rigid bodies. A body is said to be a rigid bodies if relative position of its constituent particle remain unchanged after an external force is being applied. So that type of bodies is known as rigid bodies. Okay. So basically, what is happening here? Let us consider there is a body. Okay, and the constituent particles. Suppose this is your particle one and particle two, and the distance between this is your R1. Okay, R1. So if you will apply a force, large amount of force or any type of force, if you will apply, and still there is no change, still there is a distance is only R1 between P1 and P2 after force is being applied. After force is being applied, right? What do you mean by this then? Then it means that if no change in the position of constituent particle, any particle, if you take any particle, there will be no change in the distance between these two particle. Then this type of body is called body is called rigid body is called rigid bodies. Okay, rigid bodies. So basically solid is a considered as a rigid bodies, because in solid what happens, see, if you want to see in solid what is happening here. So there is lots of atom, and atoms are combined with a large intermolecular force. So lots of atoms are there, and there is a large intermolecular force of attraction, as well as they are closely packed. So when they are closely packed, that's why they are making a solid. But if you go for a liquid, see here, there are three structures. If you go consider this three structure, for example, this is your solid. uh, let us erase all mark. Okay, let us consider this is your solid. Okay, so try to understand what is the constituent of this solid. Inside solid, how atom is been there. So atom is very closely packed in the solid. So if a body is a solid, so atom will be very closely tightly packed like this. Understood or not? So these atoms are tightly being packed like this, like this. And intermolecular force is very high. The intermolecular means the force of attraction between two molecules or atoms. Intermolecular intermolecular force is very high. Intermolecular force is very high, right? Intermolecular molecular force is very high. Okay. So if intermolecular force is very high, then what will happen? So there will be a strong bond, and due to this strong bond, what will happen? So it won't change its shape automatically. I hope you have understood. Understood. So when the strong intermolecular forces are very strong, then if you will apply a force also, then it won't change. So this is a solid body. This is a solid body, right? Now I will talk about. Now I will talk about a liquid body, right? Now I will talk about liquid body. Okay. So liquid body. In liquid body, do you know what type of structure you will? It appears like this. See here. So suppose this is a liquid part. So the atoms are very far like this, like this. So less intermolecular attraction. Less intermolecular attraction. Molecular attraction. Okay. It won't be a rigid. It won't be a rigid, right? It won't be rigid shape. So that's why you have seen that if there is a liquid and if you pour in any container, it will take its shape. So there is no rigidness at all. And when I will talk about the gas, so see here, gas has a very large separation between two atoms. Okay, so that's why very less very less very less intermolecular force. Intermolecular force of attractions are there. Force of attraction, right? So I hope you have understood this solid, this is your liquid, and this is your gas. So this is the basic difference. So on the basis of this shape only, I will talk about the basically solid and its property. You know that no bodies are perfectly rigid. So we have assumed that the body will be rigid, but even strongest object, strongest in an strongest body, strongest high strength, if you apply a force, so what is going to happen? Very few changes at least will be happen. Change will be happen. Deformation will happen, right? So if there is a deformation, then you can't say that this is your rigid body. So that's why generally no bodies are perfectly rigid. Even a steel bar, if you take a steel bar and if you apply a force, so it will bend like this. So the strongest hardness also, it won't be considered as a perfectly solid. So there is a somehow a little elasticity in this type of material. Okay, so let's discuss about elasticity now. What is elasticity? Let us consider, see here, what is elasticity? Try to understand. Elasticity is what? The property of a matter by virtue of which the body tends to regain its original shape and size after the remove of external force. Now from figure you can understand that he is jumping on this body. So his body, as soon as he is applying a force on this body bent like this, and as soon as he lift off, then what will happen? It again regain itself. It's like a rubber also you can say, or steel you can also say. So whenever any body regain its original shape and size, then the property of a body is known as elasticity. The property of a body is known as elasticity. For example, if you are taking any rod and you bend like this, so again what happened? Again it regain to the straight one. So this property of the rod is known as elastic property. I hope you have understood now, right? Elastic property. And the deformation caused due to this is called the elastic material in the object. So the object you are taking, for example, the object you are taking and you are changing its shape, and again it become on the original shape only, then this type of body is called elastic material. Okay, elastic material. I hope you have understood now. Always try to understand that elastic material means what? Elastic material means what? It means that it will regain its original shape and size after removing the external force. So here a person is jumping on this object. So this object, as soon as he jumps, so what happens? Due to external force, it changes its shapes. But as soon as he jump off, so what is happening? It again regain its original shape. So it is regaining its original shape, right? That's why the behavior or the property of this material is known as elasticity. So I hope you have understood now elasticity, and the material which have the tendency of elasticity is known as elastic material. Okay, so I hope you have understood now. Now let's go for a different topic. So what is the reason of the elasticity? You know why the body is able to be in elastic property. So see, as solid bodies are bound together by intermolecular force. So see, there are lots of intermolecular forces are there because there is atoms like this. Okay, so as soon as what is happening here, as soon as you are applying a force here and here also force, two types of force you have applied. So what is happening here? What is happening? Being an intermolecular force there inside it, you are applying a external force to overcome this intermolecular force. So what will happen? This body will deform. This body is change its shape and size. But as soon as you remove the force, so what will happen? It will regain its shape. So this is known as elasticity. So why it is regaining? It is regaining due to its intermolecular force of attraction. Okay, as soon as external force is being removed, then the body will regain due to its intermolecular force of attraction. So I hope you have understood now. So there is an intermolecular force of attraction between in the body. So if you, as you remove this, so this force will try to regain its shape and a size. So this is the basic reason for the elasticity. I hope you have got clear concept about elasticity now, right? Now there is a one term, this is known as perfectly elastic. Which type of body is known as perfectly elastic? The body which perfectly regain its original shape. For example, this is your 1 meter. When you apply a force on this both the side, so it will become 1.2 meter. But as soon as you remove force, so what will happen? It will again regain to 1 meter only. So when this happens, it means that this is your perfectly elastic. But as soon as you come to know that there is 1.1 meter, then it is not perfectly elastic, because it is not regaining its original. Okay, try to regain but not regain. So you can say that it has an elastic body but not perfectly elastic, because for perfectly elastic you have to regain, or an object has to regain its original shape and size. No any deformation should be there. Then that type of things are known as perfectly elastic bodies. So I hope you have understood this topic. Now let us consider new terms, that is known as plasticity. So before that, you try to understand from this figure. See here, when a roller is being rolled on this metal, so this is your metal, right? This is your metal. Try to understand, this is your metal, and as a roller move on metal, so what is happening? The original shape and final shape. So metal is changing shape, right? And after this, what is happening? It is permanently deformed. Permanently deformed. See here, it is not regaining its shape and size. Permanently deformed. Okay. So the ability of material to change its shape permanently is called plastic property. It won't regain its shape. Understood? For example, putty or solid mud, if you will take, or duff of wheat, if you will take, so if you change the shape, so what will happen? It won't regain at all. But just opposite, if you take a ball and if you press a ball, so what will happen? It will change the shape, and as soon as you remove the force, so what will happen? It will again regain its shape and size. Now the thing is that you have to understand that permanent deformation is happening. So the plasticity is the property of a material by which it has a permanent deformation property. So permanently it deform. It won't regain at all, right? So this is known as plasticity of the material. Now what is plastic body? The tendency of a body to recover its original configuration on the rebound of deformation, then it is said to be plastic. But the tendency of a body to recover its original configuration on the removal of deforming force. Body. So see here definition, I think there is a change, there should be a change. The tendency of body to due to which it unable to recover, tendency body unable to recover, unable, you should write here, you should add this point, very important. The tendency of a body unable to recover its original configuration on the removal of deforming force, then it is said to be perfectly plastic. Perfectly plastic. Okay, it is your perfectly plastic, right? It is your perfectly plastic material. See here, if you are just changing the shape, see original, this was original rod, and as soon as you have, what you have done, you have applied a force, and due to this force it bent like this. Now after removal also, what happened? No forces are there, so after removal also the shape remain unchanged. The shape remain unchanged after removal of a force, external force, shape remain unchanged. Okay, it means that these are the plastic body. It means that these are the perfectly plastic body. So you, in example, you can take a mud, solid mud or duff or putty, putty, just you know that putty, if you take this and just you change the shape, then it won't regain its original shape. So this type of things are known as plastic body. Okay, now I hope you have understood. Now this again I'm just revising it. Try to understand. This is your mechanical properties in which we have studied about rigid bodies. Now solid, what are the difference between solid, liquid and gas in the intermolecular, on the basis of intermolecular force of attraction as well as the placing of atoms, right? And no bodies are perfectly rigid. I hope you have understood. Now what is elasticity? Elasticity, the property of a matter by virtue of which the body tends to regain its original shape. So this is the elasticity property. If you take a rubber and if you apply a force on a rubber, so what will happen? It will change the size, change after being applied a force. But when you remove, so it will regain its original shape. That's why it is known as elastic property. Now reason I have already discussed. So plasticity I have already discussed. Okay, so region plasticity I have already discussed. Now plastic body you have already discussed. Now I will talk about a stress. So I hope till now you have now continuing this point. Stress, what is stress? So let us understood what is stress. Okay, uh, internal restoring force acting per unit area of a deformation of a body is called stress. What do you mean by this? See here, let us consider here, this is an object. Okay, this is an object and of external force is being applied here. So what will happen due to internal force of attraction, intermolecular force, so it will try to restore. So definitely if you will apply a force on any object, so what will happen? There is a intermolecular force of attraction, so it will apply in opposite direction, that is restoring force. So restoring force will act just opposite to it, right? So if you are applying an external force, so what will happen? So restoring force will apply in opposite direction. So the restoring force per unit area is known as stress. Okay, so stress can be defined as the internal restoring force per unit area. The more force, the more stress are there. The more internal restoring force will be there, it means more stress will be there. Less area will be there, so it means that more stress will be there. So stress is directly proportional to force and stress is directly inversely proportional to the area of cross section. The more thinner an object or more less area, it means that more stress it will produce. And the symbol, you should try to use this symbol sigma as a stress, symbol of a stress. And the unit is what? Force by area, so that is Newton per meter square. And if you go for dimension unit, so this will be ml minus 1 minus 2. So definitely again I am telling you what is stress. Stress is your internal restoring force by area of cross section. What type of restoring force? So take an example. So you should try to take an object. See here, you should try to take an object like this, and if you apply a force on this object, so what will happen? This object will try to apply a force in opposite direction. So as soon as you will feel that there is an application of an force opposite direction, so there will be a stress produced. So stress is generally a pressure, but it is always acting for not we can't say pressure directly, but we can say similar to pressure only, right? So I hope you have understood this situation, right? So you have now understood stress. So how many types of stress are? So there are types of stress. If you go for a type of stress, so let us discuss about type of stress. So stress are of three types: normal stress, shear stress, and bulk stress. Normally stress is now further divided into normal stress is also known as longitudinal stress, and this is divided into tensile stress and compressive stress. So I will discuss each and everything. Okay, so there is a third time that is your bulk stress. Okay, so as per syllabus, so this thing you should cover all this topic. So I will try to differentiate all the type of stress one by one. So first of all, you need to know that what is normal or longitudinal stress. When the deforming force act normally over an area of a body, then the internal restoring force set up per unit area of a body is called normal stress. So see here, let us consider there is an object like this, and you are applying a force. So your force is normal. You are applying a force here, or you are applying a tensile force here. So the force per unit area or area, it is perpendicular. See here, it is at a 90 degree. Suppose you are taking about a force here. If you are taking a force like this, and there is an area like this, so this is your 90 degree, this is your 90 degree, right? So force by area. So see here, force and area both are perpendicular to each other. Okay, then the stress produced in this scenario is known as normal or longitudinal stress. See here, if we have applied a force, see, try to see here. If you have applied a force like this in this object, and one side it is your fix, so what will happen? There is an internal restoring force which is acting in opposite direction, and you see this area of cross section which is at a 90 degree, right? So now you tell me what is the normal stress. So normal stress means what? Internal restoring force by area. Basically we are taking force. See here, this applied force will be equal to internal restoring force, right? So you should try to remember equal and opposite force will be there. As everywhere there is a Newton's third law of applicable. So if you are applying a 10 Newton force, so definitely 10 Newton of internal restoring force will be there. So I hope you have understood now. Now the force applied and the area both are perpendicular to each other. So try to understand this. Every time force is always perpendicular to the area, then that type of then the stress produced in this situation is known as normal stress. The thing is that always try to remember this, that stress is equal to internal restoring force by area of cross section. Okay, so I hope you have understood this. I hope you have understood this situation, this topic, normal or longitudinal stress. Now you know that this normal is further subdivided. This normal stress is further subdivided. See here. So this normal stress is divided into tensile stress, compressive stress, and volumetric stress. So I will discuss one by one this. Okay. So now what is tensile stress? If there is an increase in the length of the body in the direction of the applied force, then the stress produced is known as tensile stress. See, let us, this is the original length. Okay, try to understand, this is your original length of the object. When you apply the force in both opposite direction, what will happen? Its length is being changed. See here, earlier this red color was the original size, but this white color, this change in length happen. Suppose there is a length like this. When you apply a force in opposite direction, so what happened? This length got increased by del L. So this part is known as change in length. So total length is equal to L plus del L, right? Earlier it was L, now it became L plus L, L plus del L. So del L is the change in the length. Okay, so change in length. So when what is happening here? When there is a increase in the length of the body in the direction of applied force. See here, increase in the length in the direction of applied force. So length is increased in the direction of applied force because this is the direction of applied force, and this is the length in the increase. So the stress produced is known as tensile stress. The situation, see here, formula will be same, but the thing is that you need to understand that why it is known as tensile strength. Okay, and the unit will be same. Now compressive. So the word compress means what? To compress any object, you know compress word. Okay, so what is happening here? If there is a decrease in a length, see, when you compress any object, so the size will decrease. So for example, this is the length of the body L. Now you have applied a force from both the direction. So ultimately what will happen?
there is a change in a change in a length. So total length will be, now what is total length? Original was L and change in length was del L, but it reduced by del L, that is decreased in the length is your del L. So the length, final length will be L minus del L, yes or no? In while in a tensile stress, what you have got, final length is how much? L plus del L. Okay, but in compressive stress, what is happening? Final length is your L minus del L. This is the basic difference. So you can see here, stress, the symbol of stress is this. If you want to find tensile stress, so use this term, tensile subscript. If you want compressive stress, so you can use this C. Okay, so the formula will be again same, and this will be Newton per meter square. So I hope you have understood this compressive stress, right? So I hope you have understood this compressive stress. Now I am talking about volumetric stress. Okay, so what is about volumetric stress? If the normal force are applied on every one surface of the body, then it undergoes change in a volume. For example, you are applying, see here, if you apply a force from all the sides, so what will happen? What will happen? Its size will be deformed. So suppose earlier its volume was V, and the see here, now the reduced volume is smaller than this. So let us consider change in volume is del V. So what will happen? Final volume. So final volume, if I will talk about final volume, so final volume will be, so final volume, that is V dash, will be equal to original volume minus change in volume. And the stress produced in this, see here, let us consider that every from every area force is F is being applied, or P is being applied as a force. So the stress produced is known as volumetric stress. Okay, so in this type of stress, you can say that it is your directly volumetric stress and all. I hope you have understood now. Now there is a shear stress. Shear, try to understand. If you are having a figure, I have given a figure enough to understand. Earlier this was like this. See, suppose this is A, B, C, and D. So earlier the shape of the solid was like this. But as soon as you applied a force in this direction, so as soon as you are applying a force on this direction, so what is happening? So a change in angle is happening, but the volume will remain constant. Volume will remain constant, but the change is only angle change. See, this is your rigid part. Okay, you have fixed this solid from base, and if you apply this, so what will happen? It will try to move, but the base won't able to move due to why? Because it is being fixed, right? So when a deforming force acting on the surface of a body produces change in the shape of the body without change in volume, is called the shear stress. Okay, and what is happening here? The change in shape, see here, area and force are in a parallel. So or you can say force is acting tangential to the area, tangential to area of cross section. Okay, so this is all about shear stress. So I hope you have understood now shear stress. So before going to the strain topic, so if you you just go through it, I hope it will be better. Now I'm talking about shear stress. I have completed it all. Okay, now let's talk about strain. What is strain? Very interesting topic it is. The ratio of change in configuration to the original configuration is called strain. What is strain? The ratio of change in configuration to the original configuration. For example, let us consider this is an object of a length L. Now you have applied a force on opposite direction. So as you apply a force, so what will happen? Its length become L plus del L, right? The change in length is how much? Original del L. So So the strain is what? Change in configuration. So how much change in configuration happened? Del L is your change in configuration. Del L is your change in configuration, right? And earlier original configuration was L. So strain is your change in length by original length. So configuration may be area, may be anything, but we need to understand that what type of change we are talking about. So when you apply a force, so lengthwise it is increasing or decreasing. So it may happen that it may decrease. So I hope you have understood now. Strain. Strain means what? Change in configuration by original configuration. If you talk about the normal strain or longitudinal strain, so del L by del L, you can say that. I will discuss this thing. So wait for it. Now, now types of strains. So how many types of strains are there? How many types of strains are there? See here, types of strain. Longitudinal strain. First of all, first type of strain is your longitudinal strain. If the deforming force produces change in length alone, then the strain produced in the body is called longitudinal strain. See, if the deforming force produces change in length alone, see, if you are applying a force on this object, see here, or let us, I have drawn this diagram. So this is your original length. When you applied a force, so what is happening? Length is being changed. So when only length is being changed, so this type of a strain is known as longitudinal strain. So what is the formula? Change in length by original length is your longitudinal strain. Okay, so length, we are here in longitudinal strain, only length is being changed. Okay, so that type of strain is known as longitudinal strain. And if you want to differentiate it, so please write like this. Its suffix should be L, and strain, the symbol of strain is like this. So it may not find, you may not find these things in an NCERT book, but try to understand this. So if you want, so this is longitudinal strain. Okay. Now shear strains. I am talking about shear strains. There are two different types of strain. So if the deforming force produces a change in shape of the body without changing its volume. So when you are deforming, so no volume is changed, but shape is changing without changing its volume. And what is happening here? Angle is changing. See here. See, let us consider. Now let us consider that you have fixed this, right? You have fixed this and you have applied. So in this type of thing, you know that shear force is acting. And if shear force is acting, you have just now understood shear force is equal to force by area. So area is acting, force is acting tangential to the aerial surface. So what is changing? Angle is changing. So this angle is known as shear strain. So how you will find this angle? So let us see here. This is, suppose this is your x and the total length is your L. So can we write here like this? Can we write like this? So if I will write like this, so this is your phi and this is your L and this is your x. So can you see that this is your right angle triangle? So can we write here tan theta is equal, tan phi is equal to perpendicular by base, that is equal to x by L. Now if phi is very small, then tan phi can be written as phi. So it means that phi is your x by L. Phi is your x by L. Okay. So this is what all about shear strain. So there is no dimension at all. See here, x is in meter, L is in meter. So there is no dimension at all. I hope you have understood now shear strain. Now I am talking about volumetric strain. What is volumetric strain? See, if deforming force produces a change in volume alone, then the strain produced in the body is called volumetric strain. See here, if see this dotted like structure, you can see that earlier it was the solid like this. Now force is being applied from all the side. What is happening? Volume has been changed. So let us consider earlier initial volume was V, final volume was B dash, and change in volume was del V. So if you talk about volumetric strength, that is EV, so change in volume, that is del V. So let us consider change in a volume, how much change has been happened divided by original volume. So this is all about volumetric strain. So I hope you have understood now. Volumetric strain is what is volumetric strain. Okay. So I hope you have understood all the topic. Go through the video once again. If you are not getting any problem, then no issue at all. And I have already provided a link of a notes, class notes. So you should go and download that notes, so that you will able to revise it quickly. So I hope it's enough for today. Thanks for watching my videos.